Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. So, this video is all about the summary of the chapter 5 entitled Ethernet. But before that, let me give to you the definition of the Ethernet. So, according to Mariam, Ethernet is a system of wires and devices for connecting computers so that they can work together. So, we use the Ethernet for the wires and the devices to work together. So, another thing is a computer network architecture consisting of various specified local area network protocols, devices, area connection methods. So, Ethernet is now the predominant LAN or the local area network technology in the world. So, it is the Ethernet are mostly used in today's world. So, Ethernet operates in the data link layer and the physical layer. So, because Ethernet is comprised of standards at these lower layers, so it may be the best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standard of the media. So, let's start with the Ethernet encapsulation. So, Ethernet is the most wide used LAN technology today. So, as I said before, the Ethernet is the dominant. So, Ethernet operates in the data link layer and physical layer. So, data link layer and the physical layer. Data encapsulation. The data encapsulation process includes frame assembly before transmission. So, and frame disassembly upon reception of the frame. So, data encapsulation provides the three primary functions. So, the first one is the frame delimiting. So, the frame process provides the important delimiters that are used to identify a group of bits that make up a frame. So, the frame delimiting it identifies the group of bits. It identifies the group of bits that makes a frame. Then the addressing. So the encapsulation process contains the layer 3PDU and also provides the data link layer addressing. So the error detection. Each frame contains a trailer used to detect any errors in transmission. So, they have the built-in that used to detect the errors. Then, Ethernet evolution. So, since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. The Ethernet is invented by Ethernet is invented by Dr. Robert Metcalfe by the Xerox corporations. Then in 1980, the DIX standard Ethernet 2. So Digital Equipment Corporation, Intel, and the Xerox released a standard for 10 Mbps or Mbps Ethernet over coaxial cable. So, they released the standard 10 mobile Mbps over the using the coaxial cable. So in 1983, the IEEE 802.3 10 base 5 10 Mbps Ethernet overtake coaxial cable. So in 1983, the Ethernet 10 Mbps is in the thick coaxial cable. The minimum Ethernet frame size is 64 bytes and the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence field. So I said before that 64 bytes is the minimum frame size for the Ethernet. So what happens if the frame size is less than 64 bytes? So it is considered as the collision fragment or a runt frame, and it is automatically discarded by the receiving station. So they didn't allow the less than 64 bytes. If the frame size is more than 1500, it is considered as jumbo or baby giant frames. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits. Number conversion between the decimal and hexadecimal is very easy because we can convert it directly. We can divide it into 16, but it is not always convenient. So for us to easily convert decimal to hexadecimal, we need to convert first decimal to binary, then binary to hexadecimal. The MAC address is often referred to as a burned in address or the BIA because historically the address is burned into ROM or the read-only memory on the INC or the network interface card. This means that the address is encoded in the ROM chip permanently. A unicast MAC address is the unique address used when a frame is sent from a single transmitting device to a single destination device. So, unicast, it is only for one device. A broadcast packet contains destination IPv4 address that has all ones in the host portion. So in unicast, it is the destination is the only one. So while the broadcast is that has ones in the host portion. Multicast addresses allow a source device to send a packet to a group of devices. If the unicast will send in one, then the broadcast is it will send in all has one, and then the multicast is it can send to a group of devices, so many devices. Multicast addresses would be used in remote gaming, so where many players are connected remotely but playing the same game. Another use of multicast addresses is in distance learning through video conferencing, where many students are connected to the same class. So the broadcast can, or the multicast can use in our studies. So we can learn through the videos. Switch packet forwarding method. So it has two methods. That is a store and forward switch, and then the cut through switch. So let me read to you the definition of the store and forward. So a store and forward switch receives the entire frame and computes the CRC. So the store and forward switch directly receive the entire frame. So the cut through switch forwards the frame before it is entirely received. So unlike the store and forward, so the cut through forward first the frame before they accept it entirely. So addition to the cut through, so it the switches are acts the data addition to the switch addition to cut through, so the switch acts as soon as possible, as soon as they receive, even if the transmission is not complete. There are two variants of cut through. So they are the fast forward switching and the fragment free switching. So the first one is fast forward switching offers the lowest level of latency, while the fragment free switching, in fragment free switching, the switch stores the first 64 bytes of the frame before forwarding. So that is the difference of the two. So the fast forward switching is offered the lowest level of latency, and then the fragment free switching is they store the first 64 bytes of the frames before they forward. Duplex and speed settings. So there are two types of the duplex. It is a full duplex and a half duplex. So the full duplex is both ends of the connection can send and receive simultaneously, while the half duplex is only one end of the can send at a time. Destination on same network. So physical addresses or the MAC address use the Ethernet NIC or the Ethernet NIC communications on the same network. So the logical, another one is the logical address, the IP or the IP address. So used to send the packet from the original source to final destination. So the physical address use the Ethernet and NIC communication on the same network. So while the logical address, so they send the packet to the original source to their final destination. The ARP broadcast. So as a broadcast frame, an ARP request is received and processed by every device on the local area network. To sum up all of this, so the internet is we used to connect the devices and the wires. So that's all for this video. So thank you for watching.